Hi everyone, in this video I'm just going to go over some tips that you could use to try and make your bridge slightly cheaper. So the first thing you want to try and do is avoid using a template. If you can build your bridge from scratch, you could actually make it a bit smaller. Your members will be shorter, you could use fewer joints, and that way you could save some money on your bridge. Another thing you want to do is look at your load test carefully, and it'll show you which are the most load-bearing parts of your bridge, the ones that you don't want to tamper with, as opposed to which ones are not very load-bearing, like these ones in the middle. As you can see, these didn't light up very bright when I did the load test, so these ones can actually be reduced in size, or you could actually even get rid of these two members completely, and your bridge might still work. Another thing you want to do is look at this information here. So if you follow this chart carefully, you'll see two sets of numbers that you'll find useful. So for instance, if I click on member number 1, you'll see that its strength under compression is 63% and its strength under tension is 0, which means that it's being used to about 63% efficiency, as opposed to member number 2, which you can see is only being used to about 25% efficiency. So this means that I can quite safely reduce the size of this member. So I can just click on the decrease arrow and make this member a bit smaller and save some money on my bridge. So you could do that for every single member. Just go through all the information and look for members that are being used to less efficiency. So I would say if it's being used to under 50% efficiency, you can safely decrease the size of that member and improve the efficiency and reduce the cost of your bridge. Another thing that you could use is a calculator here. This breaks down the cost calculation of your bridge. You can't really do much about the material and the connection cost. I guess for the connection cost, if you use fewer joints, you'll spend less money. But another cost you want to look at is the product cost. So you'll see that I have 3 bars that are 160 by 160, and then I have 38 that are 180 by 180. So each extra type of material that you have is going to cost you $1,000. So if I change the size of this 1 bar to 160 by 160, I could actually save $1,000. So you want to go over this information carefully to see what kinds of things you can change. Another thing you could look at is the type of material that you're using. So if you click on this arrow here, you have a choice between carbon steel, high strength, low alloy steel, and quenched and tempered steel. So the carbon steel is the cheapest, but if you use the slightly more expensive materials in the most load-bearing parts of your bridge, you can make the other members thinner and save money that way. You also have a choice between solid bar and hollow tube. As a general rule, hollow tubes work better in members that are subject to a lot of compression. So if there are parts of your bridge that light up red during the load test, you can change those to hollow tubes and save money that way. So that's basically it. Another thing I wanted to mention to you is don't worry too much about the load test. You'll notice that during the load test, the bridge bends a fair bit. So the thing to remember here is that the load test is very highly exaggerated, and just because your bridge bends during the load test doesn't mean it's going to break in real life. Alright, so that's basically it. Have fun designing the rest of the challenges.